Take two chimpanzees, same forest, same troop. They might even be cousins. Now take two humans from opposite ends of the earth. Someone from Iceland and someone from Papua New Guinea. Different continents, different everything. Compare their DNA. The two chimps living on the same hillside can be more genetically different from each other than those two humans. 8 billion of us, on every continent, in every climate. And genetically, we're one of the most boring species on the planet. Almost identical. Suspiciously identical. There's only one thing that does that to a species. At some point, there were almost none of us left. Here's how geneticists think about this. Every population carries variation. Tiny differences in the code accumulating over generations. Big population. Lots of variation. It piles up over time. But if a population crashes, if it drops to a small group, most of that variation just vanishes because the people carrying it died without children. And when the population grows back, it grows back from whatever those few survivors happen to be carrying. You don't get the old variation back. It's gone. The species stays narrow forever after. So genetic diversity works like a scar. You can look at a species today and read the disasters in its past. Cheetahs are the classic example. So inbred that one cheetah can accept a skin graft from an unrelated cheetah because their immune systems can barely tell each other apart. We're not that extreme. But we are far, far closer to the cheetah than we should be. When geneticists ran the numbers on human DNA, they got a figure that has been sitting in textbooks for decades. The effective population of our ancestors over a long stretch of our history looks like about 10,000. Now, important, because this gets mangled constantly. Effective population isn't a head count. It's a model number. The size of an idealized population that would produce the diversity we actually see. The real number of humans walking around was bigger. But not that much bigger. We're not talking millions. For most of the time our species has existed, all of humanity would have struggled to fill a stadium. That's the baseline. A species so small that today, any single mid-sized city contains more people than the entire ancestry of the human race. And that raises the obvious question. What happened to us? For years there was a beautiful answer. A villain with a name. Toba. Around 74,000 years ago, a supervolcano in Sumatra erupted. One of the largest eruptions of the last 2 million years. It buried India in ash. Traces of it show up in ice cores in Greenland. In the 1990s, an anthropologist proposed the obvious link. Toba blanketed the sky. Temperatures crashed, and humanity was nearly wiped out. A volcanic winter that left a few thousand survivors huddled in Africa, and every person alive today is descended from them. It's a fantastic story. It made headlines for 20 years. And then archaeologists went looking for the bodies. They dug at sites in South Africa and drilled sediment cores from Lake Malawi. Places where you can see the ash layer itself, the exact moment of the eruption, preserved in the ground. And in layer after layer they found people, living there before the ash, living there after the ash, making tools, eating shellfish, carrying on. Whatever Toba did, it did not nearly kill us. The star suspect had an alibi. So the search moved deeper, much deeper. Not 70,000 years ago, around 900,000 years ago, long before our species even existed, back when our ancestors were still on their way to becoming human. In 2023, a team published a new statistical method for reading population size out of modern genomes, and it pointed at something almost unbelievable. Their model suggests the breeding population crashed to roughly 1,000-odd individuals and stayed there, not for a season, for something on the order of 100,000 years. I want to be honest with you here because this is new and it is genuinely contested. Other geneticists have pushed back hard on the method, and this is an open fight in the literature, not a settled fact. But sit with the picture for a second, even as a possibility. A population the size of a small village, holding on for 4,000 generations. Every human who has ever lived, every empire, every language, every war, every song, descends from a group that could have fit in a single modern apartment block and came within a bad century of never existing at all. And then it happened again. This one we're sure about. Somewhere around 60 to 70,000 years ago, a group of humans walked out of Africa. Not a wave. Not a migration of millions. As far as the genetics can tell, a relatively small founder group, and everyone alive today outside of Africa is descended from them. You can actually watch it in the data. African populations carry the most genetic diversity on Earth because they stayed in the deep, old population. And the further you go from Africa, the Middle East, then Europe and Asia, then the Americas, then the Pacific, the less diversity people carry. Every leg of the journey was a smaller group setting off, taking only a slice of what the last group had. Humanity spread across the planet by getting genetically poorer at every step. Which brings us to the thing people always get wrong. You've heard of mitochondrial Eve. One woman, traced through mitochondrial DNA, ancestor of everyone alive. And people hear that and picture a single lonely mother of humanity. That's not what it means. She wasn't alone. She lived in a population of thousands of other women, all with their own children. It's just that over enough generations, by pure chance, every other unbroken mother-to-daughter line eventually hit a generation with no daughters and ended. She isn't the first woman. She's the last line standing. And we weren't even alone as a species. Our ancestors met Neanderthals and Denisovans and had children with them. Which is why, if your ancestry runs outside Africa, roughly 1 to 2% of your genome is Neanderthal. Some people in Oceania carry several percent Denisovan. Those species are gone. Their DNA is still walking around, inside us. So, here's where all of this lands. We are not a triumphant species with a long, broad, glorious lineage. We are the narrow, surviving thread of something that came close to ending, more than once, and never had the numbers to be safe. And because that thread was so thin, everyone here is close. Not spiritually, mathematically. Push a family tree back far enough and it stops branching outward and starts folding back in on itself. Go back only a few thousand years, and mathematical models suggest you reach people who are ancestors of literally everyone alive. Every human being you will ever meet or hate or fall in love with is a distant cousin. And the distance is much smaller than it feels, which is what makes the last question the strange one. If we all came out of the same handful of survivors, so recently that our bodies still can't tell each other apart, why did we spend the rest of history convinced we were different kinds of people? I'm Sapin. See you in the next one.